Hello, in this video we'll discuss some of the main points in Neil Smith's paper Dissociation and Modularity, Reflections on Language and Mind. Neil Smith is a British linguist, now emeritus of the University College London. Now, before we start, we have to distinguish the notion of module, because this is a paper on modularity, but the notion of module that Smith uses is a bit different from the one which Smith is using. So here, following Chomsky, Smith doesn't think that the language faculty is an input system, say a parser. That seems to be Fodor's view, represented here on the left. Rather, he thinks that the language faculty must be a central resource, a system of knowledge that both language understanding and production draw upon. After all, no one speaks only English and understands only Japanese, so there must be some central resource that kind of joins them together. Smith's main point is to establish a double dissociation between linguistic capacities and other cognitive capacities. Why? Because in the end, he wants to argue for the modularity of language. We begin with the idea, then, that in order to argue for the modularity of a capacity, it is a good strategy to show that it is functionally autonomous from other capacities that one might suspect are related to it. To say that the capacity is functionally autonomous is to say that it works independently of other systems. How can we establish that a capacity functions independently of others? Well, one important source of evidence for this is provided by cases of dissociative pathology. That is, cases in which, because of an injury or illness or whichever cause, patients lose one cognitive capacity while retaining another, thus showing that the capacities can be dissociated. Now, dissociations can be single or double. Double dissociations provide by far the strongest evidence for functional autonomy. Thus, one of the standard arguments for modularity proceeds from evidence of double dissociation. So in general, then, if we look at the direction of the evidence, double dissociation provides evidence for functional autonomy, which in its turn provides evidence for modularity. An example. So what is functional dissociation? Let's give a simple, perhaps an oversimplistic example. Suppose that you encounter a kind of machine from a culture you don't know much about. It seems like its purpose is to output geometric solids. You see that it produces balls and egg-shaped things, which, in order to be scientific, you call spheres and ovoids, respectively. Now, you would like to know how it works, but, it's a precious artifact and you don't want to open it up, or you're not allowed to open it up. The question you want to ask is, for instance, suppose that you're interested in this, is there one independent subsystem that is specialized in the production of ovoids? That is there a separate ovoid maker, perhaps along a sphere maker and any other figure that it makes? Well, this is not the only possibility. There could be perhaps, a single process that assembles all the shapes. So perhaps there is a component that makes surfaces, there's another component that applies colors, and there's a single component that cuts and deforms the surfaces into their different shapes, to their final shapes. Or perhaps there are two subsystems, for instance, one devoted to spheres and the other one devoted to ovoids. And that's what you want to know. Now, luckily, although you can't peer into the mechanisms there are several of those machines around, and some of them have malfunctions. So one of those machines can produce spheres, but somehow it loses capacity to produce ovoids. So you have a case of a single dissociation, which shows, at the very least, that the ovoid making capacity and the sphere making capacity do not always go together. Now, but is this sufficient to show that there is an independent ovoid maker inside the machine? Not necessarily. It could be, for instance, there are many possibilities. It could be that the process of making ovoids is just an add-on to the process of making spheres. So perhaps there only is a sphere maker, and then some of its outputs undergo some sort of a stretching to get their egg shape. In this case, a malfunction of the stretching system would be enough to account for the pattern. Of course, there could be indefinitely many more explanations at this stage, but the presence of an alternative explanation is sufficient for our purposes. So case 1 is not enough to show that there is a dedicated, independent ovoid producer. However, suppose that we also find a second case which shows exactly the opposite pattern. Namely, it can produce ovoids, but it cannot produce spheres. Well, this would kind of go against the picture we offered above, in which the production of ovoids is simply an additional step in the process of producing spheres, right? So we have a case of double dissociation here, and thus better evidence that there is an independent process of ovoid making. Of course, this would be quite far from a definite demonstration, since additional evidence or alternative explanations could emerge that could make us reconsider this picture. Okay, back to Smith and language. Smith wants to argue against the view expressed by many people, such as Piaget and others, that language is just an expression of general intellectual ability. So one powerful argument against this view would be the existence of dissociations between language and intellectual ability. We could organize the possible cases in this respect in this 2x2 case, this 2x2 table. So we have 4 possible cases. So first, we have cases in which intelligence and language are both impaired or unimpaired. Well, these are not very helpful because there are no dissociations. The interesting cases would be those in which one of the abilities is impaired and the other one is preserved. And those would be dissociations. Just to get them out of the way, let's fill the cells in which I have marked A and B. So A would be what we would call normal people, with both language and intelligence intact. An uncontroversial case, I suppose, for cell D would be an encephalic, say someone who was born with cerebral hemispheres missing. Now to the interesting cells B and C. Some cases of aphasia would constitute examples in which language is affected, but general intelligence isn't. For instance, there are people who, after having suffered a stroke or having sustained a brain injury, lost their capacity to understand or produce language, but nevertheless retained their mathematical, mechanical, or musical abilities, for instance. However, although these are relatively uncontroversial dissociations, they are single dissociations. And we know that single dissociations are not enough to argue in favor of functional independence. So we need a case to fill cell C. What could that be? Smith proposes to look at Christopher. Christopher is someone with what is sometimes called a savant syndrome, in which serious mental disabilities coexist with extraordinary abilities. They are sometimes described as people with an island of startling ability in a sea of disability. For instance, there are mathematical savants who, say, have reduced linguistic communication and can't dress themselves, but can reduce 6-digit numbers to their prime factors in a few seconds. Or calendar savants who can name the day of the week of any given date in a few seconds, or even in less. So there are also musical savants and painting savants. However, Christopher is a special kind of savant. He's a linguistic savant. He lives in shelter accommodation because he's unable to look after himself. And his hand-eye coordination is so impaired that everyday tasks like dressing or hanging a cup on a hook are serious chores for him. So, psychological profile, well, he has a moderate to severe disability in performance tasks and is close to normal in verbal tasks. This is with respect to psychological tests. However, he is unable to master tic-tac-toe, and he fails Piagetian conservation of number tasks, which is something that small children can, and shows some, but not all signs of autism. And he fails false belief tasks, such as the Sally Ann and Smarties task, which we'll talk about later in the class. However, he can provide correct definitions for terms such as bat or hangul, and he can correctly identify the nationality and teams of various soccer players. And he recognized public figures such as Saddam Hussein and Margaret Thatcher. So he shows normal command of English syntax, which in terms of production, comprehension, and judgment tasks, right? Just like a normal, competent native English speaker. And he can integrate linguistic knowledge into simple patterns of reasoning. But what seems to be most impressive is his polyglot ability. So, for instance, Smith writes that he has some knowledge ranging from a smattering to that of an average undergraduate of Danish, Dutch, Finnish, French, German, Greek, Hindi, Italian, Norwegian, Polish, Portuguese, Russian, Spanish, Swedish, Turkish, and Welsh. And by the time of the writing, he had been exposed to speakers of Hungarian, Serbo-Croatian, and a variety of other language, and was reportedly assimilating them pretty quick. He can also identify, for instance, Arabic, Bengali, Chinese, Finnish, Georgian, Hungarian, Icelandic, Japanese, Korean, Letzeburgish, and Mongolian. So, can Christopher, as a member of the category of linguistic savants, provide the necessary second dissociation? Smith thinks it does. But the case could still be made stronger. For instance, we could obtain experimental evidence that would allow us to compare Christopher's performance with that of normal subjects in the same kind of tasks. In fact, this is the path that Smith and collaborators took. The experimental task they chose is the learning of an invented language on the part of Christopher and a control group. And the control group was comprised of undergraduate university students. The invented language was called Ipan. So, Smith and his collaborators taught Ipan to both Christopher and the controls. Now, at the beginning of the experiment, the features exhibited by Ipan were among those observed in existing human languages, so nothing peculiar about Ipan. However, and this is the interesting part of the experiment, as time went on, all the participants began to be exposed to constructions that were linguistically impossible, even though they were logically simple, computationally simple. So those characteristics were judged impossible insofar as they go against what is known, or at least plausibly hypothesized to hold of human languages in general. So the variables that were manipulated were structure dependence versus structure independence and general difficulty. And structure dependence and structure independence is because it is hypothesized that all possible language are structure dependent. More of this in a second. So what underlies the experiment and all the study is that Christopher's language learning abilities depend on his language faculty, his language module, which is specialized for the acquisition of language, but not for anything else. It's not for general problem solving. And one of the principles that characterize the language faculty is the principle of structure dependency. So, putative languages that do not respect this principle are not going to be possible. So what is this principle dependence? Well, let's begin with the fact that sentences have hierarchical structure. They're not just a sequence of words, right? They're not just a string of like beads on a string. Rather, they have also a vertical structure, so to speak. For instance, a sentence like Mary ate the sandwich doesn't just have a sequence of words, right, from left to right, but also has this hierarchy. It has a subject-noun phrase, Mary, and then a verb phrase, that ate the sandwich. And furthermore, the verb phrase is composed of a verb and an object. These two form the verb phrase, ate the sandwich. Now, the subject noun, Mary, can be replaced by much more complex noun phrases. But in each case, they play exactly the same role in the sentence, right? Picking out the eater of the sandwich. And it doesn't matter how complex or how simple they can be, as long as they can play the same role, they're going to be okay. So, Mary ate the sandwich. It could be, in that case, Mary can be substituted with the student. And that student is also going to be a subject noun phrase. It doesn't matter how long it gets or how big the phrase. The boy on the hill could also be a correct substitution. Or the woman I met in Newton could also be a substitution. Or the woman I met in Newton the day before class before the semester started could also be a substitution. And so the idea is that characteristic, that sentences arise in hierarchical structure with constituency relations, is not a mere accident, but is central. So the rules that affect word order of the sentence always take into account the structure of the sentence. For instance, the start example is yes-no question formation, in which the auxiliary is are, for instance, or a modal such as might, will, or should, which is placed after the subject, is placed before the subject. For instance, you have Mary will eat the sandwich. And how do you form the question? The yes-no question is, will Mary eat the sandwich? Well, a simplistic rule, if somebody were looking at the simplest rule, would be, well, you simply take the second word and then you put it in the front, right? That seems to accommodate this example. But this doesn't accommodate this other instance. The student will eat the sandwich, right? If we apply the same rule, that namely moving the second word at the front, we would get student will eat the sandwich, which is not really an English sentence at all. The first component that has to be taken into account is the phrase, the subject phrase, the noun phrase, the student. And so it is the auxiliary, right? In this case, the modal that goes immediately after the subject is the one that is moved to the front. Will the student eat the sandwich? And the same goes with the woman I met in Newton. Doesn't matter how long the phrase or how big the case, it is taken as a unit, right? And so those sentences can be seen as string of words. The mental algorithm for grammar do not pick out words by their linear position, such as first word, second word, and so on. Rather, this mental grammatical algorithm that we have groups words into phrases and phrases into bigger phrases. And it kind of gives each one a mental label, like subject, noun phrase, or verb phrase. And so the real rule for forming these questions, right, it doesn't look for the first occurrence of the auxiliary or the first word. Rather, it looks for the auxiliary that comes after the phrase labeled as the subject. And so, again, the point is that all rules respect the structure of the sentence. There are no rules which just take the first occurrence of is and put it into the front of the sentence, right? All the linguistic rules refer to phrases. They don't count like beats on the string, right? This is saying that grammars don't count. Well, with this in mind, then we have these kinds of cases. We have these rules that are structure independent and computationally simple. Then those rules that are structure dependent but linguistically impossible. And then you have those rules that are structure dependent and linguistically possible. So Ipan has all of these cases. So an example of a rule that is structure independent but computationally simple is a rule that they invented for Ipan, which is a process of emphasis formation, which consists of adding a suffix nog to the third word of non-emphatic sentence. So this is not independent because this doesn't mention phrases or hierarchical structure. It's just counting words, again, as if they were beads on a string. Now, in the case B, structure dependent but impossible processes would be, well, we have a case that is logically simple but linguistically impossible. For instance, in Ipan, you have this basic word order, subject, verb, object. And so to form negative sentence, the rule is to move the verb to the pre-subject position. And why is this impossible? Well, it's impossible because in no language is negation marked only by word order. You always have to add a morpheme, such as no, right, or niet, or whichever morpheme it is, right? It never works just by movement. And so these are logically simple and easy to spot, but they are linguistically impossible. Well, at least a priori, it would seem that they would be easy to spot, but we see that things are quite complex. And so you have kinds of cases: structure-independent rules, structure-dependent but linguistically impossible rules, and structure-dependent and linguistically possible rules. Now, A, B were designed to be computationally simple. And so which case would be easiest for Christopher? Which case should be most difficult for Christopher? And which case should be easy for the control subjects? Just think about it for a second. So, which case would be easiest for Christopher? Well, presumably structure-dependent and linguistically plausible rules, right? Because if he is making use of his linguistic module, and if his linguistic module works according to the structure dependence principle, he will readily pick on those examples. Now, which case would be most difficult for Christopher? Well, presumably both A and B, especially A, since structure-independent rules are, again, not covered by his linguistic modules, which is what would give him an advantage. And again, structure-dependent but linguistically impossible rules would be more in the neighborhood, but still wouldn't be covered by his linguistic module. And which case should be easy for the control subjects? Well, A and B. Why? Because they are, again, computationally simple. They're just a matter of counting, right, and putting this in and switching this. They don't have any appeal to complex hierarchies. So, on the idea that subjects are just taking this as a normal problem-solving task, they would have no problem with A and B, but C perhaps would be more difficult. And so the hypothesis then is that the controls would induce simple rules, generalizations, right? Both the structure-independent and the structure-independent but logically impossible by using problem-solving strategies. Right? And so since they have their general central reasoning capacity intact, they can use that capacity to solve the problem of this computationally simple but linguistic impossible problem. They simply don't treat them as language but as puzzles, and they're good at solving puzzles like everyone else. But Christopher will fail to induce them because, again, his central abilities are compromised, right? And remember that he can't even figure out tic-tac-toe. But his linguistic abilities won't help him here because presumably those deal with principles, or the solution depends on patterns that are outside of the domain of the language faculty, like structure-independent rules, right, or linguistically impossible rules. Okay, so this is what we would expect. But so what were the results? Well, the results were kind of messy. But according to Smith, we had a partial confirmation. So as predicted, Christopher did not infer the structure-independent rule, but neither did the controls. And he suggests that these controls were unable to suppress the architectural constraints of the language faculty and remain baffled by the process of emphasis formation. That is, they couldn't help but to see it as a language, right? They couldn't see it as a general problem-solving issue. And so, formed as a language, they were expected to see structure-dependent rules, and that didn't fit the mold, so they were confused. Moreover, structure-dependent but linguistically impossible operations were within the abilities of the control group, right? Again, as predicted. But this proved beyond Christopher in the initial stages, okay? Which, again, was among the things that we had said. So, although he made some progress after prolonged exposure, there were aspects he never mastered. So, Smith says, I take it that these results support modularist claims about the dissociability of the cognitive and the linguistic systems. And so, however, he says that the picture that arises from this is not of a Fodorian module, that they don't have the whole gamut of characteristics of a Fodorian module. I mean, he thinks that the notion that fits is that of a quasi-module. A quasi-module is domain-specific, fast, and mandatory. However, they're not necessarily informationally encapsulated, and they are a central resource. Right? They're made of conceptual, not perceptual, building blocks. And he thinks that theory of mind, face recognition, moral judgment, and even music are also quasi-modules. So, what do you think? What does he say about the possible modularity of language? Well, cheers. Bye.